All right, well, welcome to Spatial Data on the World Wide Web. So, for this first lecture, we'll see how far I get. Basically give you an overview, and do a bit of housekeeping about the module. Then, small section introducing a philosophy of data, just trying to put the course in a sort of larger philosophical context. What are we doing here? And then a short introduction to database models, which we may run out of time for, given the delays in getting set up. So that's what we're going to try and do today. So we'll start off with a bit of housekeeping. First of all, if mobile phones, please turn them off, put them away. It's nothing more annoying to me personally. Well, there are more annoying things, but somebody fiddling with their phone while you're trying to talk to them, it's quite off-putting. So please put your phones away. Don't fiddle with them. Okay, so you're here to learn GIS, or to expand your knowledge and skills in GIS. And this is what you call it. You search for GIS on Google or some search image. This is what you tend to get a picture of: a screen, people staring intently at the screen, obviously enjoying themselves immensely, looking online. And this is kind of the normal view of GIS. People say, what is GIS? Well, it's maps and computers. And this is what a lot of this course is basically about: how to use desktop GIS, how to make nice maps, how to do spatial analysis, stuff like that, how we use the data. This module is not really about that at all, and what it does is or the aim of the module from my perspective, or its overarching sort of perspective, is that I want to take you both inside the GIS, to a certain extent, what goes on inside, how do we build these things in the first place, what tools are available, and to do that we need to learn about how to do some programming. There'll be quite a lot of programming in this module. But it's also outward looking as well. It's saying, okay, here's two people looking at a screen in isolation, well, together in a room somewhere. But GIS is so much more than that nowadays. Of course, with the web-based mapping, the internet, mobile technologies, communities of people coming together to build community data sets, volunteer geographical information, citizen science, all these things. So we're both looking inside the machine and outside the machine as well. It's not really about this sort of, I was thinking of calling the surface of GIS, ArcGIS package. It's about the inside and the outside. Oops. We're inside the machine. We're going to think about the data, the spatial data, what spatial data is, how it's stored in computers, in databases, so actually the storage of data. What is data? That's one of the things that we're going to consider in this lecture here. We're talking about writing the code that operates on the data and provides us, hopefully, with a meaningful system. We not only have to write the code that actually does the manipulation of the spatial data, we need to also interested in graphical interfaces that allow users to manipulate the data, interact with the data without having to write the code. So inside the GIS, we're talking about data, code, and interface design. Outside the GIS, we're considering things like user communities. Who are the user communities? What is the role of the user communities in, say, standardizing data formats, the way we collect data? Who are the different user communities? We have professionals, groups of professionals, perhaps interested in, say, hydrological modeling. We've also got groups of citizen scientists increasingly using GIS-based technologies. For example, the OpenStreetMap project. We're obviously interested in how the internet, how spatial data, spatial information is communicated across the internet, providing support for these user communities. And we'll also consider to a certain extent how our data models and how we represent data relates to the real world, the modelling side of things. Throughout this, system reboot, temporary hold. IT systems. You've got to be patient with IT systems. So I think that's something that hopefully you'll come away from with after a year. Yeah, is a bit of a better acceptance if you don't already have it. These are incredibly complex machines and are prone to fall over, do strange and weird, unexpected stuff. To a certain extent, roll with it, rather than get frustrated. Okay, we're up and running. Oh, now we've got to go back up to the laptop. HMDI. Okay, so we're looking inside and outside, and throughout the module there will be sort of some common themes running through it, and one of the most important is the concept of, or the ideas regarding design and the implementation of software systems. So we're constantly going to be thinking about how is the best way to design things? What is the methodology we should follow if we're going to implement a database system, if we're going to implement a web mapping interface for some group of users? So the idea of design will permeate the entire module. Now all that code, all that data is, let us say, at times not the most interesting topic to lecture about and to listen about. This is a module in which building things is more to me more important than the stuff I'll talk to you in lectures to a certain extent. And I will talk to you about code. You will have lectures on various programming languages, and I will do my best to make them interesting, but it's hard. But there's also for a bit of light relief and also just a bit of pure entertainment. We'll occasionally go on little bits of flights of fancy. I'm interested in spatial visualization, ways of communicating ideas. So I may go off on a tangent and you might think, oh, well, what's that got to do with spatial data in the World Wide Web? Well, hopefully I can justify it a small amount, but there will be the times when we'll just do something different, think about other things than just minute today of code. Okay, materials, all on study space, GD7404, that's straightforward. Although I don't really use study space for any of the materials, as you'll probably discover, basically the module guide is there in the module guide section. All the rest of the materials you can access through the All Materials link here, which will give you a link which will link out to the web pages, and all materials will be supplied through these web pages rather than through study space. You will obviously use study space to submit your assignments and work as well, but basically that's all we're using study space for. The rest of the stuff will be through the web pages. Just run really quickly through these as a brief introduction page. The main page you probably won't find, if you haven't already, is the materials page, in which I will post up the various materials that you need throughout the year. So the lecture slides will go up hopefully the day before the lecture. I'll do my best, but quite often they're not put up till the first thing in the morning, depending on the situation. Then, as I say, once the lecture's been recorded, I'll make that available as a video. There are, for the database component of the module, which is basically the first half up until Christmas, there are some notes provided. So here, 3 data and database notes, RDBMS notes. Now, these notes are only provided for the database component of the module. They are also, to a certain extent, a legacy of how the module was previously delivered, particularly for distance learning modules. So I've basically come to the decision this year that I'm no longer going to maintain these notes and update them in line with the lectures because it's duplicating information. Nevertheless, they are provided, I've decided to provide them there for you, both for yourselves and for the distance learning students as a resource as well. There's also links to the practicals, so the OSGeo Live practical link there, and there'll also be often a reading link, which is a link to the suggested additional reading for the module, and we'll talk about that in due course. And there's one of these sections for each week. There is also a link where I've just simply listed the practicals because the practicals are effectively set in stone now. All practicals, 5 practical documents for the first semester, all up, all available now. So you can, if you're so inclined, through these as quickly as you want. 5 practicals, but 12 teaching weeks. So basically, they're 5 practicals that are scheduled to spread across the entire teaching block. So the fact that I put the first one in week 1, the second one in week 2, the second one, third one, 3 in week 2, don't worry about the details of that. Some of the practicals map onto the lectures. So, for example, in week 3, entity relationship modelling practical goes with the lecture on entity relationship modelling. Same thing with the next one, normalisation. There'll be a normalisation lecture and a normalisation practical. The other ones, the main Postgres one and the PostGIS ones, probably you should aim to do over 2 to 3 weeks each. And then there'll be additional time, any extra time you can put towards your assignment, which I'll explain in due course. The materials for teaching block 2 are not available yet. They will be made available in due course. So I say very simple schedule, 4 o'clock till 18 o'clock, 14 o'clock to 18 o'clock each teaching week. 2-hour lecture in this room. Oh, it's a different room. I'll put the same room there, but it is a different room in teaching block 2, followed by 2-hour practical in the main building, the main geography building in that 2005, which is colloquially known as the GIS lab. Always check OSIS. Always check, well. We'll never know when the gods have something useful to tell you, I suppose, but subject to change. I had a first year tutorial scheduled on Monday this week, or Tuesday this week, vanished before my eyes, and reappeared on Thursday. So bear in mind, we may be subject to change, room changes or something like that. Last year we weren't, but hopefully we won't this time. Schedule. Important word, indicative. Indicative meaning nothing is set in stone. Basically, I've got a reasonably good plan for what we're going to do over the year, but things will change, be adjusted slightly to deal with circumstances. For example, I tend to maybe overrun on lectures, so I have to shovel put a part of the lecture into the following week. So basically, up until week 5, just our introduction today. Next week we'll move on to the relational data model, exploring the relational database model in some detail. Week 3 we move on to learning structured query language to query data in a relational database. Weeks 4 and 5 we move on to how the design process, how do we design a database model, how do we physically implement a database model. And as I say, we've got sort of these practicals map pretty well up there onto the lectures. I've also highlighted on the right-hand side some reading from the main core texts, and I'll talk about those in a moment. I doubt we'll have the DAKW discussion this afternoon. I suspect we'll spend most of our time just setting software up and things like Second half of the teaching of this year up until Christmas after the enrichment week. After the break, we'll start adding spatial SQL into our understanding of SQL, so we can now write spatial queries onto a relational database as well as just normal attribute queries. Then we'll start adding timing as well to build spatio-temporal databases. Then we've got a number of sort of odd little lectures coming up to the Christmas period. Some more on product design and implementation, metadata and data mining, the object data model, and finally the Christmas lecture where I give you my personal tales of woe in building databases throughout my life, and joy as well, I hasten to add. And as you can see, these are just labelled as database surgeries. Basically, you come into the practical classes, you're either catching up, continuing on with the work, those 5 practicals that were initially issued, or working towards your database assignment. So that's the scheme. In the new year, we still start on the World Wide Web. So we'll have an introduction to the World Wide Web maps on the internet. We'll learn to build basic web pages, HTML, CSS. We'll think about network architectures, how the various components, software and hardware components are built that make the internet and allow mapping applications on the internet are connect together. Then we'll start learning some browser-based, client-based programming in JavaScript, basically writing programs that run in web browsers. We'll be using what's called the Leaflet Web Mapping API, which is a very popular program for developing web maps. We'll also learn how to write what are called AJAX, which is the way in which browsers can fire off requests to servers to return them data and things like that. We'll be learning a bit more about interface design. Special things do we need to know about if we're building web-based interfaces on various sorts of versus sort of desktop GIS interfaces. Then in the second half of the second teaching block, we'll be looking a bit more widely, thinking about crowdsourcing, volunteer geographic information collection. We'll be thinking about all the various types of data that exist out on the World Wide Web. Then we'll be looking at the sort of, going into the edges of the known world, so to speak, where we'll have a brief look at something called the geosemantic web, which is an attempt to break data out of silos into giant network data models, which can then be connected into knowledge networks. Quite interesting stuff. Look at how digital data is delivered through various spatial data infrastructures. Look at Google Earth, basically, and the idea of a sort of all-encompassing one-stop digital Earth. Very last week here, so is a put aside for you're going to build, as part of your second assignment, you're going to build a web mapping application, and we'll have a little presentation session right at the end where you can present your applications, get feedback, some final feedback on the work that you've done before submitting work for assessment. So that's the basic outline of the course. Texts. So if you're to buy one book, I would buy Shakar. Shakar is, unfortunately, it's not available as an ebook through the library. We do have a couple of books in the library, but for the database component of the course, I think that is the best one if you want to buy a book. Connery is available as an ebook through the library. It's a basic database development, standard undergraduate kind of database development textbook. Very good, nice, easy read, but available on the internet if you want to, or through iCat if you're happy just to read an electronic version. Obi Post-Gist in Action is a great book. There are a couple of copies in the library. However, much of the information in Post-Gist in Action, which is basically how to use the Post-Gist extension, spatial extension to Postgres, I'll talk about a little bit about software in a moment, is available online. A lot of your needs here in this module are things like, how do I write a line of code that does this? Now, while there are books that contain that information, such as OB, that information is also quite widely available on the internet. And indeed, this book, Post-Gist in Action, has a website that contains many of the bits of code that are actually in the book. So, whether you buy books is entirely your decision. This is not a module that has, as I say, a lot of the resources are on the internet. And when it comes to the web mapping side, I couldn't actually identify a single book that I thought it was worth you identifying as a core text for the web map. All of the best information is available online, or to a certain extent in academic papers. So there's no core text for the second one. On the web page, a couple of links to the, I'll provide you a couple of links to the those sources. I have listed a couple here, but they're just general a book about generally how to write JavaScript, of which there are many, many, and also one about how to write in what's called PHP, which is Personal Hypertext Programming Language, which we won't do. These are good, just basic reference guides. So, again, I wouldn't personally bother buying them unless you get to the point where you think it really would help. I mean, I own some of these books, but what I tend to do is lie in the bath and read them in the bath to get a general overview of how the programming languages works in respect to a particular problem that I'm trying to address, rather than for looking for individual solutions to bits of code. So, if you like reading books about programming languages, maybe additional reading. So I've also got a link to some additional reading. It's sort of organised into rough categories. The categories don't match up exactly to each week's lectures. Why is this? Well, because we touch on design all the way through the course. So there's papers related to design are all together in a design section, but we'll have lectures that touch on design all the way through. So whole variety of links there. Some of them are just sort of tutorials, online tutorials, useful places to find the basics of programming. Other are to specific papers, and wherever possible I've provided a link directly to the PDF, or it might provide a link to the ICAT where you can download it from ICAT. If you find any papers that you think are really good and really relevant to a particular section of the course, then please, and you think they should be generally made available, please pass on the details to me and I'll have a look at it and add it in if I think it's a good idea. So please do feedback any additional information. Spatial databases and webs on the map is a very fast moving area, so it is actually very difficult to come up with the most up-to-date stuff. Or let's say by the time something gets published in a paper, it's quite often a year to 2 years out of date. So the most up-to-date stuff is often available on web pages, blogs, and things. What do I need to pass? Okay, 2 assignments, 50% each. The details of both assignments are up on the web pages, so you can read the details online. The full spec is up there, and as part of the module guide. In the first term, you're going to do a database project. Basically, I give you some dirty data for a project. In this case, it's the data. It relates to a little study of the relationship between air pollution and respiratory disease. It's a little local study based in Kingston. It's just an invented study. I'll give you a dirty data set. You have to clean that up. You have to design a relational database to store it in. You have to upload the data into the database. You have to write a variety of use case queries in SQL onto that data. I'll go into the details of that assignment in a couple of weeks once we're up and running. Second semester, you have to develop a GeoWeb application. So you have to think of some kind of application that you want to develop for. So, for example, one year, well, this is when we had an undergraduate course, somebody did a database of coffee shops in Kingston Town Centre. Simple number of dots on a map, basically, some simple attributes for the various coffee shops, how expensive they were, whether they sell cakes, what time they were open, that kind of thing, and a little mapping interface onto that. Other people have done things on house prices, basically any subject of relevance. One person did something for the scouting organisation, showing where the various scout guide troops were across the country. Many different applications. So in that case, you come up with your own idea. You then decide what the architecture is, how you're going to build this, what software you're going to use to build this web mapping application, and you build it. And the submission is both an actual physical application with all the code that goes with it, and also a design document that documents your design process from initial ideas through interface, mock-ups of interfaces through to your delivered product. Again, details, we'll talk about details in due course. So some of you have already signed up. We have a Facebook group, Spatial Data on the World Wide Web, where you can post, if you find a useful, interesting article, blog item, stick it up there. It can also be used to discuss coding problems. So in previous years, people have stuck up their code and said, why isn't this working? I bang my head off the table for 2 days and I still can't spot it. Somebody else looks at it for 2 minutes, says, oh, you're missing a dot here. That solves your problem. You may think writing code is a rather closed, personal thing. You sit there in front of a computer, you tap away for hours on end. Yes, it is that, but the best coding is communal, and the best way to find solutions to your problems is to talk to people and to interact as a group and a community. As I say, there is nothing like getting somebody else to look at your code and to say, and often they can see in a second what you've been staring at one line of code for an hour and you've not spotted a comma that's in the wrong place. And that's all that can make the difference between, you can lose 2 days' work because of a comma. So please help each other out. Use the Facebook page for that. There is also, if you want, a Facebook page which is just generally called Kingston Centre for GIS, Kingston University Centre for GIS, where far more general posting gets done. So I basically look after this and I try and post a couple, maybe one post a day or something like that, just on general GIS information, papers that have been published, interesting little blog articles by Google. So sign up to that as well if you're a Facebook user. Of course, there's no obligation for any of you to use Facebook or any of these things if you don't want to. That's your decision. They're just there for you. Okay, so briefly I talked about software availability. So software, so we're going to use, throughout the module, we're going to use something called the OSGeo Live Suite, which runs as a virtual machine, basically a self-packaged set of programs. It runs on what's called the Ubuntu operating system. How many of you are Unix people? Linux people? Anybody touch Linux? One, okay. So you're going to be providing all the expert knowledge on Linux. Linux is just a free open source operating system. It's a various flavour of Unix. At this point, I just get lost. There's lots of different flavours of Linux. This is just one of them. You're not really going to need to learn much Linux at all. Basically how to copy a file, delete a file, rename a file. That's the only Linux you're really going to need to use. It's got a point and click graphical user interface just like Windows, so you can start and run all your programs just by pointing and clicking. So the main programs we're going to use are Postgres, which, as it says there, the world's most advanced open source relational database. This is used by industry, by NGOs. It is serious software, good stuff. So the OpenStreetMap is run, for example, on Postgres databases. So it's a proper, fully spatially enabled relational database. The spatial component of it is called PostGIS, and that's the spatial add-on to the relational database. We'll also be using a little bit Quantum GIS, Quantum also known as QGIS, which is an open source GIS package and is probably the main rival in many ways to ArcView when it comes to simple desktop mapping. We won't be using that much, but we will use it when we actually want to make a map. I think it takes us until about week 6 before we actually make a map, just to prepare you for that. At that point, we'll actually make a map, and we'll probably use QGIS just to onto Postgres within PostGIS. Then in the second half of the course, we'll be running the Apache web server and building with the leaflet JavaScript web mapping programming. So that's the software, but the languages that run with these bits of software are we're going to use. So in the first semester teaching block, we're basically learning SQL, structured query language, which is a standard query language onto relational databases. Then in the second half, in the web development side, you'll learn to program page contents with HTML5. You'll learn to write programs within the browser using JavaScript. You'll learn how to use CSS to style your web pages and your web programs. And you will learn a tiny bit of PHP, which runs on the server as opposed to client. Okay, we're probably aware of what a server and client is. A client is this computer here, my desktop. The server is some computer down in a basement somewhere that I log on to and maybe runs a database program. So we'll learn CSS, so PHP on the server, these 3 on the client, and then we'll learn to exchange data between the server and the client through using JSON and XML formats. It's probably all just gobbledygook to a lot of you now, but it's just trying to give you an overview picture of where we're going. USB sticks, you've all got them. Brilliant, that's sorted. Final thing, maybe you can't read that. I didn't make a backup disk. Every year, a student loses their work, and as a result, doesn't do as well as they should have done. It's up to you to look after your work and make sure that you don't lose work. You will be working in a virtual machine. The virtual machine is basically one giant file. It's a 12 megabyte file that will be stored on this USB drive. There is no way into this once it gets corrupted. It is dead, it is gone probably, never to be seen again. But be prepared. So make sure that you make copies of your work that's inside the VM and get them out of the VM every time you do some work. Back them up onto your H drive, your university network drive, back them up to wherever you want, your Google Drive, whatever. But make sure your life is not enclosed in the VM on this thing. They get lost and the VMs get corrupted. So please, please, please. And if you need help and advice on setting up a decent backup regime, then ask and we can see what we can do to help. Okay. So I think that's a good point, looking at the time, to have a short break. Are there any questions just about that, the organisation of the module or anything like that? Excellent. Okay, right, well I suggest we just take 10 minutes or so, get a cup of tea, breath of fresh air, stretch the legs, and then we'll carry on to finish off quickly with the other 2 bits. The smoke is, yeah.